We just can't get enough of Mars, can we? Everyone wants to go there, and astronauts are now looking at caves on the red planet where they can live once people inhabit it. The planet itself has some similar characteristics to Earth. Yeah, it's somewhat smaller than Earth, but the time it takes for the planets to revolve around themselves is also similar, which is about a day. On paper, Mars might seem like a good idea given some similarities to Earth, but there are some factors we need to pay attention to before we consider stepping foot there. The temperature. Mars might look like a scorching hot planet like a freakishly large Sahara Desert, but quite the opposite. It's really cold. Mars has a reputation for being a freezing, desolate, endless land that happens to have the largest mountain in our solar system thus far. So, within those mountains, astronauts and scientists are considering whether naturally built caves are the answer to our survival. Caves won't be the worst thing we'd live in considering our ancestors used to dwell in caves in communities. Logically, it's the best place to stay dry during a storm and keep warm. It's the best place for protection against predators like giant birds, elephants, and saber-toothed cats. We even had our first art shows in caves with evidence of cave art dated thousands of years ago. Caves are a good idea, and they can also help us save a lot of money when establishing a colony on Mars. Rather than building a fresh structure in the middle of an open plain, the cave structure will help and influence the architecture, potentially saving lots and lots of money. Going to Mars will be expensive. It's already expensive sending people to the moon and launching a rocket into space. So, we have to consider the logistics. Another thing to look out for is caves in the ground that are not necessarily stuck on mountains. Scientists believe that most potential places for humans to thrive are caves. These spaces are large enough to host large populations. So far, they identified 9 caves as large as football fields. So what would life look like if we lived in caves on Mars? For one thing, sunlight would be hard to access. By the time we reach Mars, we would have the best technology to maximize our lifespan in a hostile environment, which means withstanding the harsh sun rays of Mars. Most likely, we would dig through the caves further underground where oxygen would be pumped for everyone to breathe. People can walk around casually, thinking they're on Earth, and to exit the caves, you would need to wear a special suit. These cave colonies would have dormitories for people to live in and special spaces for colony meetings, entertainment, grocery markets, schools, and other places that are needed to sustain a colony. There would also be indoor farms to grow crops and raise livestock. A team of experts mapped out what some of the dwellings will look like on Mars. And just like on Earth, we will have apartments for young professionals, family homes, and luxury mansions. Some of the dwelling units would be placed on the surface and not in caves. One of the key elements of the design and architecture is how to build it around the natural light to brighten up the homes. Another element is how to deflect radiation and cosmic rays. Because Mars has such a thin atmosphere, sun rays and other hazardous objects easily enter Mars. The dwelling units also have to be sturdy to protect them from severe dust storms and extreme cold temperatures. Some of the living pods or dwelling units that are for couples or singles would have tunnels leading to a shared workspace and garden. Studies show that even being in the presence of greenery can reduce stress levels significantly. And on the red planet, we would definitely need some greenery. We can expect the family homes to be built within the caves, not necessarily underground. It would be tempting to head outside with the view of Mars, but the large thick glass would prevent anything from coming in and out. Those who are underground with a view rely on LEDs and camera systems to screen the surface landscape of Mars so it acts like real windows. And if you're bored of the surface, you can always switch the channel and watch something else as you please. Maybe a flowing river surrounded by trees, or maybe a penthouse view of all of New York. The choice is yours. There would be a driveway that leads to a garage so one can enter and exit easily. There won't really be a reason to exit the cave colony except probably to visit other cave colonies. In this case, we would have highly crafted vehicles that will take people from colony to colony on the surface. The vehicles can withstand harsh temperatures and would be constantly transporting people daily. Some people might live in a certain colony and have to commute to work every day in other colonies. Humans might not have to be working in dangerous conditions or on the surface. We would have robots that will do that for us. The thing about robots is that they don't need to be human-shaped to do a job. However, before transporting humans to space, we would need to create some human-like robots and land them on Mars. With the exact physical form, we can determine what would happen to people if they were on Mars. We would have robots for specific tasks, helping us with everything. Let's not forget artificial intelligence plays a major role in monitoring the systems and updating the functionalities of the colony. It'll know when certain systems need fixing, adjusting, renewing, and changing. We also need people to keep an eye out for anything out of the ordinary, and also to make sure people are behaving and not breaking the law. Getting to Mars would be the earliest obstacle we will face. We've already launched some robots to explore the terrain and conduct some studies. At first, we would send robots to test the conditions and to build most of the infrastructure. To build a proper colony, we would have to send out young couples willing to dedicate their lives to the future and the future of their children. It won't be easy. In fact, there would be a variety of people with different professions and specializations to help establish the colony. People would have to work and establish a local economy. We would need scientists, doctors, farmers, teachers for the children, and engineers to maintain the structure. It will take time for the colony to reach a substantial size, but it's all part of the process. Even the spaceships would need to be large and sufficient to house thousands of people traveling from Earth. Of course, by then, most of the dwelling units would have been built, and people would have already picked out their houses, depending on if they were single or if they were about to start a family. Once the colony has the necessary professionals it needs, then come the other people who wish to start their life on Mars. People would need entertainment, so musicians would find a place in the colony. We can't expect everyone to go out on a nice sunny day to the beach, but perhaps one day, when the colony is large enough, there can be an artificial body of water with the same elements as the beach. Livestock animals would also be shipped from Earth to be raised on Mars, where they can populate for our nourishment. We can also bring most of the animals and establish a wildlife sanctuary for everyone to enjoy and for the animals to thrive. For now, humans are planning on reaching the Red Planet sooner than we think, and who knows, maybe you can be one of the first people to sign up and have your own little dwelling unit far away from Earth.
Imagine something terrible happening to Earth and humans having to leave it as fast as possible, and you have to decide which planet will become your new home. Which one will you pick? Probably the first planet that comes to mind is Mars. It's relatively close. Like Earth, it's also a rocky planet. It even has an atmosphere, even though it's much thinner than what we have on our planet. But at the same time, the North Pole on Earth would seem balmy to you in comparison to Mars. On the Red Planet, the average temperature is minus 80 degrees Fahrenheit. The most radioactive areas on our home planet might seem harmless if you compare them with the surface of Mars. But what if we terraform Mars? Could we keep transforming the Red Planet until it becomes capable of supporting human life? It would be an enormous feat. Mars is an extremely dangerous place. Should you teleport there right now, without any protective suit or anything, the gas in your blood would instantly turn into bubbles. You can probably imagine the consequences. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, and well, who's next? If we still decided to terraform Mars, we would need to create a stronger magnetosphere. We've got this protective magnetic layer on Earth. It shields us from the sun's ultraviolet radiation. The Red Planet would also need a thicker atmosphere, again for protecting us from harmful space stuff better. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. For us to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the Red Planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Right now, there is some water on Mars. The atmosphere of the red planet is too thin for this water to stay in its liquid form. But under the surface of the planet, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. If liquid water existed on the surface of the planet, it would make it easier for us to start growing plants, and plants, in turn, would begin to produce oxygen. But first of all, we would need to start the warming process. How? Well, Elon Musk suggests using nuclear energy to make Mars more livable. He says it could be done by creating a continuous flow of low-fallout nuclear fusion explosions above the atmosphere of the planet. It could create something like numerous artificial suns. It could warm the planet, melting the frozen ice caps, which would then thicken the atmosphere, causing even more warming. Other strategies for Martian global warming include the diversion of asteroids into the poles of the planet, or the large-scale production of greenhouse gases that could help us heat the red planet. Or we could create a giant space mirror, as huge as the side of Mars. It would reflect tons of additional sunlight onto the planet. The problem is all these projects would have exorbitant costs. They would also require serious upgrades in our technological capabilities. Could there be an easier and cheaper way of terraforming the red planet? It seems so. Casey Hanmer used to work in NASA's Jet Propulsion Laboratory. Now he's the founder of a startup hoping to create carbon-negative natural gas by pulling carbon dioxide out of the atmosphere of our planet. He's also made a proposal to terraform Mars for a modest $10 billion. Sounds alluring. So, what is his idea? Mass-produced small solar sails. These are already existing technologies, even though they appeared only recently. Such sails use sunlight to propel themselves, like ships use the wind to sail. These solar sails could be launched into low Earth orbit, and after that, they would fly themselves to Mars. There, they would reflect sunlight onto the night side of the planet. According to Hanmer's calculations, a decade of such launches could result in a 1% increase in temperature on Mars. Hanmer also believes that we could mass-produce solar cells at cell phone factories, all because a solar sail would need a processor, a camera for navigation, and some electronics to be able to transmit data, just like a smartphone. In other words, solar sails would be like small satellites using cell phone technology. Each of these sails would also need a sail of its own, a thin space blanket weighing about 2 pounds. When unfurled, it would span around the size of 2 basketball courts. Would this plan involving solar sails enable people to terraform Mars? Hanmer doesn't think so. Even if we put loads of money into solar sails, they would only make the red planet warmer and more humid, but they still wouldn't be enough to make Mars suitable for human life. Most scientists are also very skeptical about the very idea of terraforming this cold, dry world. They say that carbon dioxide and water vapor are the only greenhouse gases present on Mars, but there's just not enough of them to change the situation. Let's say we manage to melt the polar ice caps with the help of Elon Musk's nuclear technology or solar sails. And still, this ice will only release enough carbon dioxide to bring the atmospheric pressure to 1.2% of what it is on Earth. Plus, most of the carbon dioxide gas wouldn't be accessible, and we wouldn't be able to mobilize it. Even if we decided to go through an energy-intensive process of the extraction of carbon dioxide from the planet's soil, dust, and minerals, we'd still only get the atmosphere to a mere 5% of where it needs to be. Water is another problem. It is salty on Mars. It might even be as salty as the oceans on our planet. But these salts aren't what you find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. Who's next? On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then they could use a UV disinfection unit. This would also help get rid of any foreign molecules, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the red planet, but only if they bring the right purification equipment that can deal with any water quality. Because, however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Anyway, back to terraforming the red planet. Once you start thinking about it, some worrying questions arise. Who is supposed to decide whether we should start this process? When should we start it? What if there's some form of life on the red planet, like indigenous microbes we haven't spotted yet, and our attempts to change their home will disturb them? What if they don't survive these changes? Now, what do you think? Share your thoughts in the comments. Hundreds of spaceships take off from Earth's surface and head toward Mars. Fast forward 7 months, and this space fleet of ships is near the red planet. Soon they will all land, and a few thousand people will become citizens of Mars. Perhaps they will never return to their home planet, because there will be absolutely all conditions for a comfortable life here. It takes time and many expeditions to create a self-sustaining colony on Mars. Here is how, step by step, people might build a full-fledged city there, with factories, hospitals, apartment buildings, and even clubs and restaurants. First, we need to pick a time to launch the rocket. A launch window opens once every 780 days. That's when the distance between Earth and Mars is the shortest. In this case, the journey will take about 6 to 7 months. Let's move to the launch pad. Here, we see the spacecraft connected to a booster rocket. Ignition! The booster sends the spacecraft into the air. It then undocks and lands back on Earth. At the same time, the spacecraft's engines start and it makes its way to Earth's parking orbit. To make this ascent, the ship has used almost all its fuel and now needs refueling. To do this, we use our booster again. A huge crane places another spacecraft on the booster. There are huge fuel tanks inside the ship. The booster launches from Earth and takes the refueler into orbit. It docks with the spaceship and fills it with fuel. The journey through space may need a total of 5 such refuelings. And for the first mission to build a colony on Mars, we need 5 spaceships. So that's about 25 launches from Earth. Considering that the booster costs $230 million, the refueler $130 million, and the ship itself is $200 million, the price tag on the mission is pretty impressive. So, ignition. Fast forward in time, and the first 5 ships descend to the surface of Mars. These ships haven't brought the first humans. They carry only payloads, like fuel and water supplies, oxygen for breathing, and medical supplies. There are also first living modules, waste management systems, and a huge number of solar panels for generating electricity. Before landing, one of the ships launches a system of satellites into orbit. It'll provide communication on the red planet. So, the robots begin their work on Mars. First, a whole bunch of little rovers line up and unfold solar panels. Their total area reaches the size of 7 soccer fields. They're much less efficient on Mars than on Earth. Frequent sandstorms fill the working surface of the panels with sand. But at the same time, the strong winds of the red planet also help to wipe the sand away. Other rovers, equipped with powerful drills, begin searching for water in the Martian soil. When they find water, people will begin producing fuel. We'll combine carbon dioxide from the atmosphere with the mined water at a high temperature and under high pressure. It'll result in getting methane for rockets and oxygen for breathing. Since February 2021, Mars Perseverance rover has been testing the technology for oxygen extraction. It has a box inside. This is the Mars Oxygen IRSU experiment, also called MOXIE. This thing pulls Martian air inside and then, under high pressure, takes one atom of oxygen from carbon dioxide. Such a thing, about the size of a shoebox, can provide enough oxygen for one astronaut to breathe. But if you build the same mechanism but the size of a large factory, it'll produce oxygen for an entire colony and release the rest into the atmosphere of Mars. Another group of rovers is working to turn the surface of Mars into a landing zone to prepare for the next step in colonizing the red planet. By this time, the robotic population of Mars has been working on these tasks for 2 years and 2 months, and people on Earth have been waiting for a new flight window to open. This time, not 5, but 12 spaceships are coming to Mars. 10 of them are cargo ships, which bring construction materials, fuel, and other supplies, as well as a lot of scientific equipment and 3D printers. 2 other ships carry the first interplanetary astronauts. The doors of the spaceships open, and 30 heroes set foot on the surface of Mars for the first time in history. These people are scientists, engineers, and doctors. They have undergone a strict selection and long training to become the first people to conquer another planet. And these guys don't have a return ticket. They'll have to stay on Mars for 2 years. The astronauts live right in their spaceships and try to get used to the unusual conditions on Mars. The temperature here is about minus 80 degrees Fahrenheit. Also, the gravity on Mars is 2.5 times weaker than on our home planet. That means a person here can jump twice as high and lift heavier objects. But the muscles in human bodies have a hard time getting used to such a difference, so astronauts can't work full-time. The first thing they do is unload cargo ships and deploy life support systems. Some people are experimenting with turning Martian soil into material for 3D printers. Others are setting up greenhouses and cultivating soil to grow plants. The human waste recycling system the robots brought here is used to make fertilizer for plants. 2 more years and 2 months have passed. We see a launch of a spaceship, not from Earth, but from Mars. The 30 astronauts have completed their mission and are on their way home. It's easier for spaceships to take off from Mars because the gravitational force here is less powerful. At the same time, ships are launched from Earth. They'll bring nearly 100 new inhabitants and even more cargo to Mars. When this space fleet arrives at the red planet, the astronauts can taste the first food grown here. 3D printers begin building homes on Mars. They print outer shells from Martian soil and plant waste. These shells will protect the dwellings from solar radiation and strong winds. And inside the shells, people will build permanent houses. They're inflatable and are equipped with modules brought directly from the spaceships. These houses have living bays, research bays, and communication centers. The construction goes on for 2 more years until the next flight window opens again. Some astronauts leave Mars, but more and more people come here with every new mission. They no longer live in spaceships. There are comfortable underground houses and 3D printed shelters. Most of the food is already produced on Mars. A new generation of robots works together with farmers. Other robots help to build even more houses to accommodate the ever-increasing human population. 2 more years have passed. Various space agencies launch their missions to Mars. There are more people, more scientific equipment, and even tanks with fish. In 2035, Mars and Earth are at a record short distance, so people send a huge fleet of ships with astronauts and construction materials. By this time, the human colony looks like a small city with many interconnected domes. Its inhabitants have already begun building an underground network of tunnels to move between houses, laboratories, and factories. They've also built the first hospital. 2 years later, the population of Mars reaches the 1,500 mark. Almost all of these people will become permanent residents of the planet. 4 years and 2 more launch windows later, the first restaurant opens its doors. Also, the construction of a nuclear power plant begins. Once it's finished, the Martians will no longer need constant supplies from Earth. From above, the colony looks like a small town. There's a farming section where food is grown, a living section, and a factory district. And with each new mission, people bring more and more solar panels. Now their total area equals dozens of soccer fields. All this allows the astronauts to feel at home. They also don't have to wait for food supplies from Earth. 20 years of the human colony on Mars. Its population is now about 30,000 people. Workers begin to bring their families to Mars. The first schools are built here. 30 years. The population is already over 100,000 people. The colony's infrastructure allows it to be completely self-sufficient. People produce enough food, get enough fuel and oxygen. Around this time, the first plants start growing in Martian soil. There's more and more oxygen in the planet's atmosphere. The trees planted in greenhouses contributed to this. The greenhouse effect from all the human activity helps warm up the surface of Mars, if only a bit. People still have to wear spacesuits when they go outside. It will take many more years until people will be able to breathe on Mars like they do on Earth. Gradually, rivers and lakes will appear. Green plants will cover most of the land. And then the inhabitants of Mars will be able to go outside without an oxygen helmet and call the red planet, now green, their home.